All right, this is video number 1 for 6.2. In 6.2, you're going to be using the properties of exponents that we've learned previously. And those properties were, if you have a common base, exponents add. If you have an exponent raised to an exponent, exponents multiply. If you have a negative in your exponent, you can make it positive by dropping it to the denominator, or if it's negative in the denominator, you can make it positive by bringing the base to the numerator. That changes the sign of the exponent only. The other property that I used was anything to the power of 0 is 1. So now, instead of m and n being integers, you're going to have fractions in your exponents. For example, you could have 9 over 9 to the negative 4/5. Well, we've got fractions in our exponents now. That's what makes them rational exponents. So when I go to add these together, I'm going to be looking to have rational exponents when I'm done. So I'll look at that as if it's 5 over 5, which is just 1. So I see a negative exponent in the denominator, so my first step is going to be to take that and move it to the numerator. When I bring that up, it becomes positive, and now I'm adding fractions in my exponent. So I'm going to have 9 raised to the power of 9/5. I could write this as a radical. Think about what we talked about in 6.1. This is equivalent to the 5th root of 9 to the 9th power. If your problem comes to you in rational exponent form, you should go ahead and leave your answer in rational exponent form. Next example. When you have your fractions and they multiply, we have 6 to the 2/3, and that is raised to the exponent of 1/2. So this is one where we multiply exponents because it's an exponent raised to an exponent. So we end up with 6 to the 2/6. When you multiply fractions, remember you multiply straight across the top and straight across the bottom. And when you're done, make sure you do look and fully reduce. Again, this could be written as the 3rd root of 6 to the power of 1, so we don't need to show that. But again, if your original problem was in rational exponent form, your answer should probably be in rational exponent form unless they ask you to change it into radical form. One more example. You have some kind of challenging problems in this section. This is number 3 through 14 in the book. So I'm looking at number 10. I don't think it's one of your homeworks, but it's similar to one you'll have in your homework. It's 12 to the 3/5, and it's times 8 to the 3/5. So we can't put these together because their bases don't match. It's a 12 and an 8, and the bases have to match to add the exponents. And it's all raised to the power of 5. So this is the one where we have distribution. We'll distribute this 5 to both of the exponents, and then you'll see that this becomes 12 to the 3 times 5 over 5, which is 15/5, which reduces to 3. So I have 12 to the 3rd, and I have 8, again, same thing, to the 15 over 5, which goes to the 3rd. And I think in your homework they do want you to go ahead and type this into your calculator, 12 to the 3rd times 8 to the 3rd, and come up with the actual answer for this. And we get 8, 8, 4, 7, 3, 6.